and this is section A4, Appendix 4. Just a review on working with rational expressions. And the big tip, the big pointer, the thing to remember with rational expressions is you want to, anytime you can, factor. Factor anytime you can, and cancel, simplify as much as you can. So a big part of this is just, one is remembering how to factor, it's remembering some rules of exponents a little bit, and then just adding and subtracting fractions and dividing fractions is where a lot of us usually kind of make some mistakes. So we'll just do some examples. The other thing that when we're working with rational expressions, and this will be more important in the next section when we talk about rational functions, is we need to be careful with the domain. Because anytime we're dividing by a function, we don't want to divide by 0. So we have to be careful if we're dividing by 0, because sometimes we'll factor something and we'll cancel it out of our expression. But if you can't divide by 0 in the expression that you start with, you can't use that number that makes the original expression 0. You can't use that in what you end up with after you simplify. And I'll talk about that when we do an example. So I just want to go through a couple of examples of the different types of problems that we're going to work with here. So let's say we have 2x squared y divided by xy minus y. And we're just simplifying these. We're not solving anything. We just want to simplify this. So what are we going to do with this one? What can we factor? So do we have a common term in the denominator? Y. We can factor that y out. Y times x minus 1. And now what can we do with the y in the numerator and denominator? We can cancel that. So we get 2x squared over x minus 1. And that's as far as we can go with this one to simplify it. And in our original expression, y can't be 0. If we had y equals 0, it would be dividing by 0. But y doesn't even show up in this expression, so we don't have to worry about it. We don't have to worry about y equaling 0 because all we're working with in this expression is x. So that's as far as we can go with that one. So that one's pretty easy. Let's look at another one. X squared plus 8x minus 20. Divided by x squared plus 11x plus 10. And we want to simplify that. So when we see these quadratics, the first thing you should think of when we're working with rational expressions is factor, and maybe we can cancel something. So let's factor the top. So how are we going to factor x squared plus 8x minus 20? Plus 10 minus 2. And how are we going to factor x squared plus 11x plus 10? Plus 10 plus 1. All right? So now before we simplify, let's look at this expression. What do we have to be careful with? What numbers are going to make my denominator 0? Negative 10 and negative 1. So I'm going to make a note up here that we can't have x equal negative 10, and we can't have x equal negative 1. Now if we cancel, because we have negative 10 in the numerator and denominator, I can cancel those. And I just get x minus 2 over x plus 1. So this tells us the x plus 1 in the denominator tells us we can't have x equal to negative 1. So we're okay there. But we canceled out this factor that doesn't let x be negative 10. So we have to make sure that we note at the end that x can't be negative 10. Because if x is negative 10 in our original expression, it would make our denominator 0 and we'd be dividing by 0. So we're not allowed to have x equal 10 in our final expression either, because our final expression comes from this original one. Yes, Cedric?
Why do we need to know what you can't have?
What we're going to do in the next section is talk about rational functions, and we want to know where the domain of our function is restricted. So if this were a function, our domain would be restricted at x equals minus 10. We couldn't use x equals minus 10 in this function. Okay? That's the reason we're interested in that. All right, let's look at another example. So factor and simplify as much as possible. Pay attention to your domain. Let's look at a multiplication problem. 4y minus 16 divided by 5y plus 15. And we're multiplying that by 2y plus 6 over 4 minus y. And we want to simplify this. So let's factor. What can we take out of this term? We can factor out of 4. So we get 4 times y minus 4 over, what can we take out of this? 5. So we get 5 times y plus 3 times, what can we take out of this? We can take out a 2, factor out a 2. 2 times y plus 6 plus 3. Thank you. And out of the bottom. Now, here in the top I have a y minus 4. It would be nice if I could cancel a y minus 4, but I have 4 minus y. What can I do with that? Take it out a negative 1, factor out a negative 1, and I get y minus 4. If I distribute this negative 1, I get minus y plus 4, which is what I have here. And what y values do I have to be careful of? What y values are going to give me a denominator of 0? Y equals negative 3. So we can't have y equals negative 3. And we can't have y equal 4. Because either one of those is going to make my denominator 0. Now we can cancel. So I'm going to cancel the y minus 4 and the y plus 3 both cancel, and I end up with 4 4/5 times 2 over negative 1, which is negative 8/5. And y cannot be negative 3, and y cannot be 4. Yeah. What's that? Oh, yes. Thank you. Y cannot equal 4. So this is our simplified expression. Let's look at another one. Any questions before we go on? I'm just trying to do one example of each type of thing that we're gonna work with. So let me switch pages here. We're going to add a fraction this time. 2x minus 1 over x plus 3 plus 1 minus x over x plus 3. And we want to simplify this. So in order to add fractions, we have to have what? Common denominator. Do we have a common denominator here? Yeah. So I can just rewrite this, since we have a common denominator, I can just rewrite this as 2x minus 1 plus 1 minus x, all over our common denominator, which is x plus 3. And that equals 2x minus x is just x. Negative 1 plus 1 is 0 over x plus 3. And we haven't canceled anything out of the denominator, so our domain restrictions are okay. We can't have x equal to minus 3, but our fraction tells us that already. We didn't cancel anything out. So that's as far as we can go there. Any questions before we do the next example? All right, this is the last one, and then if you have questions from the worksheet, I'll answer those. This one, we're going to simplify a complex fraction. So we have x minus 4 divided by x over 4 minus 4 over x. And we want to simplify this. Now, before we do anything, we need to work with this denominator. But let's look at the denominator before we do anything and figure out, is there a value of x that would make my denominator 0 or undefined? X equals 4. So we have 4 over 4 minus 4 over 4. So we can't have x equal 4 here. And is there anything else that's going to give us a problem? 0. If I put 0 in here, that makes this, I'm dividing by 0 in this little fraction, and that gives me 0 here, so that's going to give me a problem. So x can't equal 0. So let's make sure we keep those in mind as we keep going forward. So we need to, in order to simplify this denominator, what do we need to do with this denominator? What do we have to have here to do this subtraction in this parentheses? We have to have a common denominator down here. So this is x minus 4. We're going to work with just the denominator now. What's our common denominator? How do we get our common denominator? Our denominator is going to be 4x. So we're going to multiply this fraction by x over x and this fraction by 4 over 4. Because our common denominator is going to be 4x. So this is x over 4 times x over x minus 4 over x times 4 over 4 to get my common denominator. And that is going to be x minus 4 over x squared over 4x minus 16 over 4x. And now I can add these two fractions because I have a common denominator. So this is x minus 4 over x squared minus 16 over 4x. Now, when I divide by a fraction, what do I have to do? Multiply by the reciprocal. Very good. So I'm going to say that this is equal to, I'm going to go over here, equal x minus 4 times the reciprocal of this fraction, 4x over x squared minus 16. I'm just going to write this as 1 to remind myself that that's a fraction. Now what do you think we're going to do? Factor the x squared minus 16. So I get x minus 4 times 4x over x squared minus 16 is x plus 4, x minus 4. And I can cancel now. Cancel the x minus 4. And I finally get that this is 4x over x plus 4. And my domain restrictions, we said x can't equal 4. And we also have x not equal to 0. Right, so this, what we need to be careful of, this tells us that x can't be minus 4. What we're trying to keep track of here is the factors that we've canceled out. So we canceled out the factor that would give us x equals 0 when we simplified this fraction, and we did the same thing for x equals 4. We simplified that, so we can't really see that in our final answer. So we have to keep track of that with our final answer. But our final answer tells us that x can't be minus 4. You don't need to re-say that. You can if you want to be safe, and it wouldn't be wrong. It's just these we've gotten rid of in our simplification process. Okay? So these are the examples of the basic types of things that we're going to need to do to simplify rational functions. Did we need to go over any from the worksheet?
Could you just do one as like 8 examples?
From the worksheet?
Yeah.
Okay. Which
8.3.
Is there a particular one?
Just number 1.
Number 1?
Yeah.
Okay. So this is the 8.3 number 1. We have 4x or 2x to the 4th over x to the 5th times 6x over x to the 3rd times x over 4. So you could do this lots of different ways. You could simplify each fraction, or you could multiply everything on the denominator and the numerator and then simplify. So I kind of, just my personal preference, I would multiply everything out. So I get, on the numerator, I get 12 x to the 4, 5, 6, 12x to the 6th. And in the denominator, I get 4x to the 8th. 5 plus 3 is 8. And that leaves me, all of these cancel, and that leaves me with a 2 here. And I get 3 over x squared.
So what is the 4x to the...
Oh, what I did here, let me go back. I'll erase. So what I said was 12x to the 6th over x to the 8th. I said all 6 of these x's cancel in the top, and I have x to the 8th, so I have 2 left in the bottom. So that gives me an x squared. I have six of them up here and 8 of them down here, so I have 2 left in the bottom. Do we want to see another one from the worksheet?
I'm down, but I'm not going to.
Let's look at
Yeah, let's do some.
the one. Let's do a couple, at least one from the back where we're adding and subtracting. Anybody want to pick one out? Number 18 on the back. So we have a long expression here, x over x minus 5 minus x squared plus 25 over 25 minus x squared plus 5 over x plus 5. All right. So the first thing that I see here is I have an x minus 5 and an x plus 5, and I have a 25 minus x squared here. So I want to see if I can simplify this so that my denominator, the factors in my denominator, are just x minus 5 and x plus 5. So I'm going to rewrite this as x over x minus 5. And if I factor out a negative 1 down here like we did in our other example, I'm going to write this as x squared plus 25 over negative 1 times x squared minus 25 plus 5 over x plus 5. And now this minus 1 and this negative sign are going to combine to make a positive sign. So that's going to be x over x minus 5 plus x squared plus 25.
Will the negative there at the top still be negative though?
But I have a negative and a negative. So negative 1 divided by negative 1 is still positive 1.
But doesn't that only apply to the denominator?
It's the same as multiplying this whole thing by a negative. Okay? X squared minus 25 plus 5 over x plus 5. And now I can, I'm breaking this down into a lot of steps here. You wouldn't necessarily have to do all these steps. I'm just showing you how I would think about it. So I can rewrite this now. I'm rewriting it a lot more times than you would have to. Plus x squared plus 25 over x plus 5 times x minus 5 plus 5 over x plus 5. So I just factored this x squared plus x squared minus 25. All right, so what is our common denominator going to be here? To add these fractions. X plus 5 times x minus 5. So I have to multiply this by x plus 5. So I get x times x plus 5 over x minus 5 times x plus 5. This one's okay because I have my common denominator already. X squared plus 25 over x plus 5, x minus 5. Plus, and I have to multiply this by x minus 5. So finally I can add my fractions. I have a common denominator, so I can write this as x times x plus 5 plus x squared plus 25 plus 5 times x minus 5 all over x plus 5 times x minus 5. And now we can simplify our numerator. So I'm gonna distribute everything here. So I get x squared plus 5x plus x squared plus 25 plus 5x minus 25.
Why can't you cancel stuff out?
Um,
Because you have x plus 5 from the bottom and from the top.
we have to remember to cancel it. It has to be common to everything. In order to cancel it, we'd have to have an x plus 5 in every term in the numerator, or x minus 5 in every term to cancel it. So it has to be common to everything. And this is all over x plus 5 times x minus 5. Now we're going to simplify this. I get 2x squared plus 10x, and my 25s cancel out. And we're getting close to the end now. X plus 5 times x minus 5. I can factor something in the numerator. What do I want to factor out of this in the numerator? 2x times x plus 5 over x plus 5 times x minus 5. My x plus 5's cancel, and I finally get 2x over x minus 5. And we have to remember that x can't equal minus 5. On the worksheet, we weren't as concerned about this as we will be today and going forward. But x can't be minus 5 because we cancel that one out. So I did a lot of steps. You wouldn't necessarily have to do every single one of those steps. I just wanted to show you step by step how the kind of the procedure of going through these. All right, I think that's enough. Let me give you your homework. The homework is from today is actually I think a little less complicated than the worksheet. This is on page A43. A43 in the appendix. All right, there you go.